A single drop of water can contain a universe of complex chemical reactions, influencing everything you taste. This hidden world of molecular transformations is the fascinating realm of food science and cooking chemistry. It explains why your favorite meals taste so delicious and how simple ingredients become culinary masterpieces. Understanding these principles unlocks a deeper appreciation for the food we eat every single day. Think of cooking not just as preparation, but as applied chemistry happening right on your stovetop. Each ingredient, from a humble potato to a ripe tomato, is a collection of molecules waiting to react. These reactions create the textures, aromas, and flavors that delight our senses. For example, the Maillard reaction, a browning process, creates hundreds of new flavor compounds. It's responsible for the golden crust on bread and the savory notes in roasted meats. But how does this intricate dance of molecules actually begin when you apply heat? When heat is introduced, the kinetic energy of molecules increases dramatically. This energy causes bonds within the food's molecules to break and reform in new ways. Sugars and amino acids, commonly found in food, are the key players in the Maillard reaction. They collide and rearrange, forming complex ring structures and volatile aroma compounds. This isn't just simple caramelization. It's a cascade of hundreds of simultaneous chemical events. And then something unexpected happened. Some of these new compounds are volatile, meaning they float into the air. These airborne molecules are precisely what your nose detects as enticing aromas. Similarly, the whey protein's denature when heated is crucial for cooking eggs. Heat causes the long, coiled protein chains in egg whites to unravel and tangle together. These tangled proteins trap water, turning the liquid egg white solid and opaque. But that's not the strangest part. The exact temperature dictates the final texture. For instance, the pectin in fruits breaks down with heat, allowing jams to set. Pectin molecules form a gel network, capturing water and sugar to create that familiar jammy consistency. Emulsification is another key process, like when you make mayonnaise or a creamy vinaigrette. This involves blending two liquids that normally don't mix, like oil and water, into a stable mixture. An emulsifier, like lecithin found in egg yolks, has parts that attract water and parts that attract oil. It acts as a bridge, allowing oil droplets to disperse evenly throughout the water-based liquid. Wait until you hear what comes next. Without proper emulsification, your sauce will separate. Consider the humble act of baking bread. Yeast produces carbon dioxide gas through fermentation. This gas gets trapped by the gluten network in the dough, causing it to rise beautifully. Boiling water, the gluten itself, is involves formed from proteins in fascinating flour when they are physics and hydrated, and chemistry needed.
It's like a microscopic scaffolding holding the gas bubbles in place for that airy crumb structure.
Boiling water, the gluten itself, is involves formed from proteins in fascinating flour when they are physic. Water molecules gain energy, move faster, and eventually break free from the liquid's surface as steam. The pressure of the atmosphere affects the boiling point, which is why pressure cookers work so efficiently. They increase the pressure, raising the boiling point and cooking food much faster. But that's not the strangest part. Water's unique properties are essential for life and cooking. Its ability to dissolve so many substances makes it the universal solvent in culinary applications. Fat-soluble compounds contributing to flavor are released by oils and fats during cooking. Acidic ingredients like lemon juice can denature proteins, tenderizing meat or curdling milk. Think of how citrus marinades work to make tough cuts of meat more palatable. The science behind fermentation also creates unique flavors in foods like yogurt, cheese, and pickles. Microorganisms consume sugars and produce acids or alcohol, transforming the food's profile. And then something unexpected happened. These microbial processes can even preserve food. The acidic environment created by fermentation inhibits the growth of spoilage bacteria. Understanding these mechanisms allows chefs and home cooks to control outcomes precisely. It transforms guesswork into predictable, repeatable culinary success in the kitchen. The precise temperature for searing a steak to perfection is a chemical consideration. The right amount of salt not only enhances flavor, but also affects moisture retention in meats. Even the choice of cooking fat impacts flavor and texture due to its chemical composition. Butters, milk solids can burn at high temperatures, while vegetable oils are more stable. Wait until you hear what comes next. The way spices release their volatile oils is another chemical marvel. Heating gently toasts them, intensifying their aroma and flavor compounds. This science explains why certain cooking techniques are better suited for specific ingredients. It's the reason why poaching yields tender fish, while grilling creates a smoky char. The subtle browning of onions in butter is a slow Maillard reaction producing sweetness. This fundamental understanding empowers you to experiment and innovate in your own kitchen. You can troubleshoot common cooking problems with scientific insight rather than frustration. Why did my cake sink? The science of gluten development and leavening explains it. Why is my sauce grainy? It's likely an issue with emulsification or starch breakdown. But that's not the strangest part. These principles apply from fine dining to fast food. Food science is the invisible ingredient that elevates every dish we enjoy.
It's a continuous journey of discovery into the molecular magic of food.
If you found this culinary chemistry fascinating, subscribe for more incredible explorations. Like this video if you learned something new, and share your favorite food science fact below. Subscribe to explore more amazing discoveries, and let me know in the comments what fascinates you most.